Let's talk about ping. I've gotten questions here and elsewhere about how to sync things up across clients in a multiplayer game. This is something where certain people are experts. They dedicate their whole life to this, and that's not me. However, because I'm doing it right this nanosecond, I happen to have an example already set up. So let me talk a little bit about this and how Unreal specifically deals with this. I have currently set us up to have an atrocious ping. You know the setting that Unreal considers bad for testing purposes? Bad network? Yeah, that's trivial. This is truly a bad network. So how does it feel when we're moving around? Well, look at that. We definitely see a fair amount of delay, some jitters, and we are desynced as to our position. We are no longer anywhere near each other. Look at how far apart we are on these two clients. We're more than a meter apart. This is bad, right? Well, is it? This is something where we have to decide what we want. See, we just got teleported to the same spot. We just got synced up. How your game reacts to bad ping, long latency, it's a game design thing. There's no way around it. You aren't going to know what buttons a player has pressed until long after they've pressed them. That's how it works. You got to transmit that data up to the server, and then the server has to transmit it down to the rest of the clients. So it's very, very easy to end up in an awkward situation if your network is not great. Now, if you're making a Street Fighter game, that's obviously going to be very, very ping intolerant. You need to be absolutely sure that your players have the lowest possible ping because it is literally unplayable with very much ping at all because it's so reaction speed requirements, heavy. And if you're playing Final Fantasy XIV, this is probably fine. You can play through all of the content, casual content in Final Fantasy XIV with a full second of ping. I've done it. So this is one of the situations where how you balance your game and what sort of measures you take to correct problems is going to end up being incredibly important. Unreal mostly assumes a low ping. It's an action game framework. It assumes that you're going to be working with action game tolerances, meaning that if you shoot someone in the face, you want to hit them in the face and not shoot at wherever they happen to be a second from now, right? So that's why Unreal is built around the idea that a bad ping is at most 300 milliseconds, which is like not really that bad. It's bad, but it's not. It's bad for an action game, but it's not bad for like an MMO. So what are we going to do? We want to change things to be more in tune with our game and our ideas. And in order to do that, we have to understand what's going on. So there are a couple of things at play here. And the fact that we have such a long ping lets us see those things very easily. So the first thing at play is that we are seeing a movement being replayed on all three spots. It's being replayed on my local client, on the server, and on the remote client. So to me, on the local client, my movement feels extremely smooth and instant. I feel great. This is perfect. I feel no ping at all because it's all happening on my client, my local client. The server doesn't get that information for a random amount of time, and so the server will try and play back that same communication, but because it has a delay on my inputs and that delay is kind of random, it's not going to play it back with quite the same fidelity. And then the long-range client downstream will also receive arbitrary updates from the server about where I am and what I'm doing, so they'll have an even lower fidelity version. But the thing here is that all of these versions, whether they're on my client or downstream, they are usable. I'm going to know that that guy has got a hell of a delay. I'm going to know that they are rubber banding. But they're not rubber banding to the point where I feel like the game is broken. They're rubber banding to the point where I'm like, yeah, okay, I can probably still work with this. I can probably still work with this person as a crew member or whatever. Because sure, they're rubber banding, sure, they're moving around funny, but they're not really like glitching. They're not doing weird stuff, right? And that's because there are two methods to respond to a server's authority. Because we are playing the same movement but delayed an arbitrary amount of time, one of the more popular things to do is to smooth us to the proper location, which is what you see on the remote client on the left. If I move on the right, the remote client on the left will see me slide. See how I'm sliding? I don't really teleport, I slide. Now the animations pop around just because that's the animation blueprint trying its best, but the character doesn't really pop. They slide into position, and that easing helps to try and keep things from feeling too, out of place. On the other hand, on my side on the right, when I have to do a corrective animation, I tend to teleport. I rubber band. I just pop straight to where I need to be, which you'll see any second here. I guess the error between this two character positions is low enough that the server keeps putting it off. But basically, because the client needs to have as fast and as responsive a time as possible, they will simply teleport to wherever they're supposed to be rather than sliding, because that sliding might, interfere with your ability to respond properly. So they just teleport you. Oh, there, we did it. We teleported. The thing is that whether we're sliding or teleporting, whether we're easing or rubber banding, we're still looking into the situation where there is an arbitrary amount of time passing and the server doesn't know what you heard and what you didn't hear, because there's a lot of packet loss. So if I were to do something and it were to take 500 milliseconds to get to the server and then 500 milliseconds to hear back from the server, that means that if the server's communication or if my communication gets lost in transmission, it'll be a full second before I know I have to resend that transmission. So, for example, what happens when we want to sync up actions between two clients? We need them to actually show the exact same thing at the exact same time for, like, demonstration purposes or whatever. It's an animation and they have to all be animated at the same moment to make it play correctly or whatever. Well, in those cases, we can tell the server to take authority. So if I were to press space and stretch, you can see how our stretches are synced up, even though there is a completely random amount of delay between the clients and the server. Now, they won't always stretch up because packet loss will in fact cause problems, but if it's just time delay, this will almost always work out because the server is responsible for replicating this value to the clients, and it understands how to do that in a fairly time-independent manner where the clients will all stay relatively well synced up. The problem is that is not 100% true. It's okay for things like stretching, but it's less okay for something like a giant white board that kind of just floats in the background. This here is not very well synced up, as you can see. So what's going on there is that this is a level sequence, and level sequences don't automatically play synced up with other level sequences on other clients. But there is a toggle you can press on the level sequence that just syncs it up. Problem is, it syncs it up to what the server kind of sort of thinks is global time. And as you can see, it's not terribly accurate. So this is an issue, and it's in fact something that people complain about a lot on the forums. The simple fact of the matter is that Unreal's ability to sync a timer between clients and itself and the server is not great. And that's especially bad for me because I'm making a game about the ocean and I have to sync up 1,000,000 miles of waves. Good news is waves don't respond to player inputs. So I don't have to worry about whether or not the players are affecting the waves. But the bad news is I do need to have a rock solid amount of time that has passed in the game world so that I can sync the wave patterns up between all the clients and the server, since the waves do affect how boats float. And there is no really nice timer that does that. They're all accurate to this level, which is just nowhere near accurate enough. Now, obviously, if the latency goes down, if we come down here and we bring the latency from absolutely terrible to average, now when we come in, you can see that it's actually very, very close to being properly synced. So maybe that's okay. Maybe it's good enough for you. It really does depend on what sort of game you're running and how much latency your systems can work with. And even the stretching, which was like really aggressive, like a half second or full second delay, even that happens pretty quick here. So that's probably perfectly fine. When you're pressing a stretch animation, you don't need it to be stretching on the nanosecond you press it. It's probably more important to have it sync up with other players, right? So it's up to you. Do you want to have that thing where the client, the server, and all of the other clients have different opinions on exactly where you are and what you're doing, and they sync up eventually using teleporting and sliding? Or is it more important that they start synced up even if it delays everybody? It's a good question. And of course, the other question is, hey Unreal, when are you going to have a clock that friggin' works? All right, have a good one.